Hello, and welcome to FPGA Design for Embedded Systems. What is a data register? A data register stores data for later use. How can we make a data register in VHDL? Here is an example circuit. Data 3 down to data 0 with Q3 down to Q0 outputs. Clock, load, and reset. In the case of the VHDL, we have our entity, clock, reset, and load, data input, and Q output. In our if statement, we have reset equals 0, then Q output equal to 0, 0, 0, 0 for the bus output. So this is asynchronous reset. Here's the synchronous portion of the design. Else if rising edge clock, then if load equals 1, Q gets the D output. If we wanted to create a shift register from D0 input to D1 to D2 to D3 output, this is what the circuit would look like. Here's the entity, clock, reset, shift, D0 as our single bit input, and Q as our bus output, 3 down to 0. And here's our architecture. If reset is 0, then our bus output, Q, gets all zeros. And here's our synchronous portion of the design. At rising edge, each time the rising edge occurs, we will evaluate this circuit. If shift is 1, then we shift each of the bits within this rising edge clock process. Q0 gets the D0 input. Q1 gets the Q0, Q2 gets the Q1, and Q3 gets the Q2 at each rising edge. This circuit we've shown explicitly with each of the bits, Q0, D0, inputs and outputs. We could also use shift left logical or the shift left Q1 function as provided in the IEEE standard library. This is an example of how to create a binary counter circuit. Here we have data input and data output, reset, load, enable, and clock. And one side note, in VHDL, in order to overload operators like Q gets Q plus 1, we need to turn on some options inside of the Model Sim library for 2008. Right-click on your design.vhdl, go down to Properties, and check Use 1076 2008. This will allow the overload operators to operate inside of Model Sim. Here's our entity, clock, reset, load, and enable, D, data bus, Q, data bus output. If reset is 1, then Q output gets 0. So this is asynchronous. And then else if rising edge clock, this begins our synchronous portion of the design. If load is 1, Q gets the D input bus. Else, if enable, then Q gets Q plus 1. Here's where we need -2008 enabled within Model Sim. Q gets Q plus 1 to overload the operator. If we wanted to create a register file, here's a circuit diagram. We have write data, write address, write enable, and clock feeding a set of registers and a mux output. Here's our entity, and in this case, here's a new item called a generic. So we've set data width as a fixed integer equal to 8. We've set our address width as a fixed integer, value 2, and this will flow throughout the rest of our design. So you can see our port list here, we have wdata defined as data width, which is value 8, minus 1, so that'll be 7 down to 0. Our write address and our read address are a width minus 1, which is value 2. 2 minus 1 is 1, down to 0. So it's a 2-bit wide write address and read address. And the same thing with read data. Data width minus 1, down to 0, with data width being equal to 8. And here's our architecture. In this case, we're going to define a brand new type, array type, from 0 to 2 raised to the a width minus 1 of type standard logic vector, data width minus 1 down to 0. Now that we've defined this type, we can create an instance of this. We're going to say it's a signal of array reg, that's the name of our array, of the new type that we've just created, array type. So to use this array type, rising edge of clock in our circuit diagram, so we've got a synchronous register file. If write enable is 1, then our array reg, which we've used as our array type, is set to write address, location gets written to from write data. And we've had to add some conversions here, which are built into the standard logic library. To integer and unsigned of W address. Why did we have to convert that for array reg? Because our array reg is defined as standard logic vector, and we have to convert those values to integer and to unsigned to provide the right type of pointer inside of our array type. And our read data gets array reg of to integer unsigned of read address. In this video, you've learned how to describe synchronous circuits, data registers, shift registers, a counter, and a register file.